Good day, viewers. I've come again. This is Furanoses Johnson. We want to proceed on the cyclic structure of monosaccharide. So please let me remind you to share this video, like it, and subscribe. And be reminded again, we have started a physical class with WAEC, NECO, JAM, pursuing entrance into nursing in Christ Rock Academy 5 to 7 every day, because there is solar power that is 24 hours and the environment is conducive for learning. Christ Rock Academy is the venue at Total Junction, Sapley Road, kilometer 8, Benin City. Let's go. Now let's look at cyclic structure. Cyclic structure of monosaccharides. Cyclic structure of monosaccharides. I want to tell you that now monosaccharides now cyclicize and then they form a cycle when present in aqueous environment. That is, environment that contains water. If you pour them inside water, they dissolve in the water and they form a cyclic structure. So the two major cyclic structure of a monosaccharide is usually the one you have Pyranoses. That is, Pyranoses is a 6-membered ring. 6-membered ring obtained from the structure of the hydrocarbon ring called pyran. Then another one we have is Furanoses. Furanose is a 5-membered ring. 5-membered ring gotten from the structure of a 5-membered ring hydrocarbon called furan. You get Furanose from furan and Pyranoses from pyran. Now these two Pyranoses and Furanose structure, they were postulated by a scientist called Award, and that's what we call the Award projection structure. So we still have some other rings like both conformation, envelope conformation. Those are purely biochemistry, so that we will not discourage our O-level students, make the work too cumbersome for them. Now, let me tell you the ring structure of a simple sugar occurs by a process called mutar rotation. Somebody else should define mutar rotation. Mutar rotation. Now, this is the interconversion of hemiketal, interconversion of ketone or alkanal with alcohol form hemiketal or hemiacetal group. Don't worry, those students of biochemistry in 200 level will understand what I'm talking about, but let me just try to break it down. Now, for example, let's go to look at a glucose molecule. 1, 2, 3, 4, 5, and 6. CH2OH. Then I have something like this. I have OH, I have H, OH, I have OH, I have H, I have H, I have OH, I have H. This is D-glucose open chain. D-glucose open chain structure. Now, something can happen like this. When you pour it inside water, something will happen. Now, there is going to be interaction between this carbon number 1, which is alkyl group, and the penultimate carbon, the second to the last carbon, OH group here. Let's look at it. Let's assume this carbon represents this number 1, this number 2, 3, 4, 5. So let's call this one now carbon number 1, which bears what? It bears double bond and what? And H. Then we take it to this carbon number 1 now, number 2 now. Then carbon number 3. Then carbon number 4. Then carbon number 5. And then 6. Don't forget, this is the sixth one, CH2OH. And this penultimate carbon number 5 has what? It has H, which is coming down. Then it has OH, which is coming like this. Now let's go back. In carbon number 2, you have what you have here. OH is down. Anything that is at this side is down. Anything that is here is up. Hydrogen is up. Then carbon number 3, which is this one, OH is inside because it is at this side. Then H is here. Then carbon number 4, what happens? OH is where? OH is down. OH. While what is called hydrogen. So there is going to be an interconversion here. I put an arrow here. So between this group and this OH group, something will happen. Let's see what will happen here. Now, let me redraw this. There will be an interchange. CH to OH. H. Here we have H, OH, OH, H, and here what do we have? We have H up, OH down. Now, what is going to happen is that this OH will leave its position and come and replace this O. So this O will be replaced with this OH. That's interconversion. Then what happens? This O will leave its position, will stay here. You know it has two bonds. One bond will come here, another one will come here. Then what then happens? This hydrogen will remain like that. So what we have here is now, and another thing is that if the H is up and OH here is down, you call it alpha. So this is alpha D glucopyranose. Alpha D glucopyranose. This is alpha D because OH is what is up. H is up. So this one can also give you you can also have an isomer of that one, which is going to give us CH2OH. Then we have this. We have this. Okay, this is H. This is H inside, OH outside, OH inside, H outside. Then I have what down? What am I having down? OH down, H up. So now, then I can have my OH up here and H down here. when H is down, we call it beta D, glucopyranose. Beta D glucopyranose. It's an isomer of that one. So if you still check it, it's still what? 6 is 1, 2, 3, 4, 5, 6. H12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. O6, 1, 2, 3, 4, 5, 6. So that is that. So with that knowledge, you will know that fructose that we usually have as this, CH2OH, we have CO, we have COH, okay, H, OH, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I have CH2OH, I have OH, OH, H, I have OH and H. This is fructose, D-fructose, open structure. So this one can also form, so interconversion will take place here too. So now you can have, okay, this is the first carbon. The first carbon is what? Is a CH2OH. This one, then is now joined to what? Is joined to okay. Let's start with the C, the one that bears the O. Let me take it down. O. Then at this side you have what? You have CH2OH, which is this one. The next one, if this is carbon number 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6. So sorry, this is CH2OH. Now, so what are we going to have? This 1, 1, 2 now. So carbon number 3 will be here, 4 will be here, carbon number 5 is here. Then I have 6. Carbon number 6. Okay. Okay. This is carbon number 5 now. And you will see that this carbon number 5 has two things. It has OH. Then apart from that, it has H. So let's put the H here. And it has what? CH2OH. Which is this one. This last thing here. CH2OH. So an interconversion will happen here. So then let's apply this. Where is carbon number 3 here? H is down, OH is inside. Unlike glucose that H is inside. Here, no. So then here, what is down is OH and what is here is H. So we have that. So then this one can interconvert again. You can have something like this. So let's go. So let's come to this place. We have our C. Now let me still draw it the way it used to be. CH2OH. Then here I have this one. OH is inside, H is outside. Then I have C. Then this is OH. This is C. Don't forget I said I have OH and I have what? H and I have what? CH2OH. Now interconversion is taking place. This OH will leave here and come here. Then the double bond oxygen will stay at the middle here. The first bond will come here, the second bond will come here. So what you have here, now if OH is down, then this is what is representing H. Oh, this is what? Alpha D fructofuranose. Why furanose? Why not pyranose? Because this is 5-membered ring. Oh, this is carbon number. This one will not be what? H. Okay, so that is that. Now, you can also have the beta form of fructofuranose. The beta form now, we have O, C. Now, here now you have OH up, CH2OH down, then you have this, you have this, you have this, you have OH inside, H here, you have H here, OH outside, you have what here, H, and you have CH2OH here. Then, so this one is what? This is a beta D Furanose. Now, then you can have, if it is a ribose now, just try it by yourself. Ribose now is going to give us something like this, D-ribose. If it is a, you have OH and you have H, because it's 5 carbon. So we have this OH, everything is OH outside. Then you have H and you have CH2OH. This one is what? Alpha D ribofuranose. Now, do you know that in DNA structure, this one is present in RNA. In DNA structure, we can also modify this one to have something like this. To have something like this. So we can have OH, H. Now, here I have, before I used to have H and OH. And here I have H and OH. Then I have CH2OH here and I have H here. I can remove the oxygen here so that it will not be hydrogen, hydrogen. And this one is becoming what? This one is, if H comes out, that's a beta D ribo deoxy, beta D 2' deoxyribose, ribofuranose. Now, so this one is present in DNA at carbon number 2. The oxygen is lacking. We now call it what? Deoxyribose sugar. That is where DNA gets its name, deoxyribonucleic acid. So this one is present. While ribonucleic acid is present in RNA. When we get to genetics in biology, we'll talk about that. Now, another thing to tell you here is that all this structure, you can also have them as this bond line mutation. Bond line mutation can also give us something like this. You can also have something like this. So we have hydrogen, OH, you have OH, hydrogen, then here I have hydrogen, OH, then here I have CH2OH, and I have what? H. So then if I have my OH up, my H down, you see what? You see beta D Pyranoses. So that is that. So this one I can also have it as what? What is it? So can have, so you can go and try other ones. This can also have something like this in this form. So in the next class we are going to look at all this D. How did I get it? That is isomerism in glucose. We are going to look at that, look at epimerism, look at anomerism, there are stereoisomerism, and so on and so forth. So please, these are the ring structures that we have. So for monosaccharides, so in the next class we talk more. I remain my humble self, Ademola Johnson. So please like this video, share it, and subscribe so that any video I post will get to you. So, and don't forget, we have a physical class here in Christ Rock Academy where there is a constant light between 5 and 7:30 every Monday to Friday in Christ Rock Academy, Saple Road, kilometer 8 at after Ajib at Total Junction. I'll see you next time. God bless you. Have a wonderful day. Ademola Johnson. Thank you very much.